So in this video, I'm going to talk about how to represent an extensive form game using a game tree. So a game tree consists of nodes and branches. Nodes and branches. Nodes are dark circles and branches are arrows that emanate from the nodes. Nodes are where things happen. So players are assigned nodes where they take actions. So to understand how to represent a game using a game tree, let's consider a simple game. Let's say we have a contestable market. So we have a contestable market. Contestable market is a market where currently there is a firm that has monopoly, but there are no entry barriers, meaning new firms can enter anytime they wish and take the monopoly power away from the incumbent firm. So let's say we have two firms. So one is the incumbent firm that has currently a monopoly in the market, and there is another firm that is a potential entrant. So the incumbent firm wants to keep its monopoly power intact, and therefore, it basically tries to signal to the potential entrant by using some price mechanism. That is not a profitable business, and therefore don't think about joining this industry. Airline, routes could be a good example of contestable markets. Many cities have just one airline, operating on a particular route, but new airlines can always join if they think it's going to be profitable route. So here, let's say we have Delta. So we have two players playing the game. One is Delta, One Airlines, which is an incumbent here. And let's say United is the potential entrant. So Delta has been assigned the initial node. So you can use a dark circle to represent the initial node. And let's say Delta has two strategies. So Delta can choose a monopoly fare, so price that a monopoly firm would charge, or it could charge a competitive fare, a fare that would prevail when there's a perfect competition. So think of high or low price, right? So Delta will announce its price. So these are the two strategies that Delta has to play the game. Think of them two actions that Delta can take as its initial node. And then United will observe what Delta did, and then United has two decision nodes. So these are the decision nodes for United. So you can write U here and U here. And United has two strategies to play the game. Let's say United can enter and undercut the Delta's fare. So United can enter and undercut Delta's fare. That's one strategy. Or United could stay out, meaning doesn't fly on this route where Delta is flying. And then on the bottom node, so if Delta chooses to charge a competitive price, then United has again two strategies: enter and undercut, and stay out. So I'm using prime to basically distinguish that you are at the bottom node, but the strategy is the exact same. And then let's say the game ends. So then you have the terminal nodes. So game will end. These are the terminal nodes here. And the terminal nodes will result in some kind of payoffs or profit here. So we can use some numbers to denote payoffs. So let's say if Delta chooses Monopoly Fair and United enters and undercuts Delta's fair, then Delta is going to make a loss of, let's say, $1 million. And United is going to make a profit of $1 million. And if Delta charges Monopoly Fair and United decides to stay out, then Delta is going to make a Monopoly profit of $2 million. And we'll assume that United is breaking even, so it makes a zero economic profit or normal profit. And Delta, if it chooses competitive fair and United enters and undercuts, then both of them will end up making losses of 0.5 and $0.5 million. And if United stays out and Delta is charging competitive fare, then they both break even, make zero economic profit. So this is how we represent an extensive form game. The game is a dynamic game. It's being played in stages. So there are two stages to the game. Here, stage one is the initial, node, and then you have a stage two, right, where United gets to play the game. So this is a very basic representation of a dynamic game. Here we are assuming that we have perfect information. So we have perfect information, meaning both players are aware of each other's strategies, and they're also well aware of the payoffs associated with each strategy here. But it is always possible that a game could be, where United doesn't know what Delta had chosen, what kind of strategy Delta is choosing. So if you have a situation like that, then you can connect the two decision nodes with dashed line, and that means you have just one information set. So dashed line is telling you that United doesn't know where it is on the upper node or the bottom node, meaning it's not aware of what Delta had chosen. So a game can always be depicted as an asymmetric information game where one party has more information than the other party. And so Delta knows what it's going to choose, but United doesn't know here what Delta had chosen. So this is how you represent by using a dashed line.